Why America builds 1 mile of highway for $50 million and China only for $6 million. America spends $50 million to build 1 mile of highway. China builds that same mile for $6 million. You heard that right. The same asphalt, the same concrete, the same overpasses, the same lane markings for $6 million. That is a $44 million gap per mile, every mile, across a network that now stretches longer than the distance from Earth to the moon and back. Twice. And here's the part that blows most people's minds. It is not about cheap labor. Strip out every single labor cost from a Chinese highway mile. Replace every Chinese worker's wage with a fully loaded American union rate. The price moves from $6 million to maybe $7 or $8 million. You are still looking at a $36 million gap with no explanation. And that is just the beginning. Hit a quick like and subscribe so you don't miss the next one. By the end of this video, you're going to understand exactly why America cannot build a road for what China builds a road for, and why that changes how you see everything from trade policy to the future of American cities. That gap is not an accident. It is not corruption. It is the physical result of 4 systemic decisions made decades ago that almost nobody in Western infrastructure debate examines directly. Before the cost breakdown, you need to understand the starting point, because in 1988, China did not have a modest highway network. It had 0 miles of expressway. And that is where this story begins. The country that started from zero. Picture a map of China in 1988. You're looking at a country of 1.1 billion people, roughly 4 times the population of the United States at the time, packed into a landmass of similar size. Now picture that map with no expressways on it at all. Not a partial network. Not a work in progress. A blank. 0 miles. Nothing. At the same moment, the United States had already completed over 46,000 miles of interstate highway, a network large enough to loop the Earth nearly twice, connecting every major city, every major port, every manufacturing hub on the continent. One of the greatest infrastructure achievements in human history. China had a different problem entirely. 73% of its workforce, roughly 400 million people, more than the entire population of the United States today, was locked in the rural agricultural interior. On the eastern coastline, special economic zones were opening. Factory clusters were forming in Shenzhen, in Guangzhou, in Shanghai. The coastal economy was waking up, but it could not breathe. The workers it needed were hundreds of miles away on roads that turned to mud in the rain. Here is the detail that puts everything into perspective. The Chinese government announced a national expressway grid of 85,000 kilometers, 53,000 miles, roughly equivalent to circling the Earth twice, across some of the most geologically hostile terrain on the planet. Mountain ranges, river deltas, active seismic zones. For a country that had never built a single expressway kilometer before, the analogy that fits here is not complicated. Imagine you have never baked a loaf of bread in your life, no oven, no mixing bowl, no recipe, and you have just told your family you will be running a commercial bakery within a decade. That is the position China was in, not behind schedule, not under-resourced, starting from an ingredient list with nothing on it. What happened next was not a miracle of cheap labor. It was a decision about knowledge, specifically about who gets to keep it after the project ends. And that decision is the reason everything else in this story was possible. The first chapter of the cost gap was not written in a budget spreadsheet. It was written in a contract clause from the early 1990s that almost nobody remembers. And that permanently changed what China was about to build. How China kept the blueprint. When China decided to build its first expressway, it hired the people who already knew how. European and Japanese engineering firms arrived with their design manuals, their survey equipment, and their supervisors. The first project was 18 kilometers, about 11 miles. Calculation went directly into state-owned design institutes the moment it arrived on site. The foreign firms received their fees. They went home. And China kept everything they brought with them. This is not industrial espionage. This is a procurement strategy, one of the most effective technology transfer mechanisms ever executed at national scale. Here's what most people get wrong about this part of the story. Most analysis of China's infrastructure program focuses on scale, the kilometers, the bridges, the tunnels. What gets almost no attention is the speed at which China stopped needing anyone else's help. The first project used foreign expertise at almost every stage. By 1996, 8 years later, Chinese state-owned enterprises were designing, engineering, and constructing expressways without a single foreign consultant. 8 years from zero institutional knowledge to full technical independence on one of the most complex categories of civil engineering that exists. Every foreign consultant carries a billing rate, a mobilization cost, a profit margin, and a currency exposure. Eliminate that layer entirely, and you have already shifted the economics before moving a single cubic yard of earth. But the knowledge transfer story is only the setup. The real cost revolution did not happen on flat ground in Shanghai. It happened when the network ran out of flat ground entirely, when the expressway program pushed west into terrain that laughed at conventional construction timelines, and China was forced to invent something that had never existed before. That invention is sitting in a mountain valley in Guizhou province right now. It weighs 900 tons, and it builds bridges the way a factory builds cars. The assembly line that replaced the construction site stand at the bottom of a mountain valley in Guizhou province in the early 2000s and look up. The walls rise hundreds of feet on either side. The river at the bottom is fast and cold. No flat staging area, no weather shelter, nowhere to store wet concrete while it cures. A Western team would have started negotiating a timeline extension. China asked a different question. Not, how do we build a bridge here? But how do we stop treating this as a construction site and start treating it as a delivery address? Here's the part that changes how you think about every bridge you have ever driven over. Cast-in-place concrete construction, used for the majority of American highway bridges, works like this. You build temporary support structures. You pour on site. You wait days to weeks for it to cure. You repeat for every section. Every pour is unique. Every section needs its own formwork. In a mountain valley with unpredictable weather, that process becomes almost impossible to control. China's answer was prefabricated segments. And to understand it, think about how a cardboard box factory works. It does not build boxes on the rooftops of the buildings that need them. It builds in a controlled environment, to a precise standard, and ships wherever they are needed. China built temporary factories near each major bridge site, producing standardized concrete segments to identical dimensions across the entire national network. A segment from Yunnan was dimensionally identical to one from Guangdong. The molds were reused thousands of times. Production was industrial, not artisanal, but manufacturing the segment solves only half the problem. The other half is placing a 900-ton section with millimeter-level accuracy across a mountain gorge with no ground support beneath it. That is what the SLJ 900/32 was built to do. 91 meters long, nearly the length of an American football field. It straddles completed bridge sections, advances on rails, picks up a precast segment weighing as much as 9 fully loaded cement trucks, and lowers it into exact position. Crew of 15 technicians. What would have required hundreds of workers and weeks of scaffolding becomes a repeatable, weather-independent operation measured in hours. Here is what this does to cost. Every additional day on a construction site is a day of equipment, rental, labor cost, site overhead, and insurance exposure. Compress the schedule, and you compress every one of those line items simultaneously. The SLJ 900/32 is not just an engineering achievement. It is a cost compression machine that happens to build bridges. The assembly line logic cascaded through tunnel boring, road base preparation, drainage installation. Standardize, prefabricate, deploy purpose-built machinery. Turn every construction site into the last stop on a production line that started somewhere else. That explains construction speed. But speed alone does not close a $44 million gap per mile. For that, you need to go back to the first moment of a project, before a single engineer sets foot on the ground, to the question of who owns the land the road needs to cross, because the answer to that question is worth more money than any construction efficiency you could name. The land. Nobody had to buy. Before a highway project in America breaks ground, the lawyers are already working. Because in America, the land the highway needs to cross belongs to someone. And the Fifth Amendment says the government must pay fair market value for every single parcel, not a negotiated discount. Fair market value, determined by independent appraisal, subject to legal challenge, in a process that can take years. In rural corridors, land acquisition averages $3 million per mile. In suburban zones, where most new American highway miles are actually built, it averages $12 million. In active urban corridors, $30 million per mile. $30 million before a single construction worker has touched the ground. Here is the brutal catch. This is not a flaw in the American system. This is the American system doing exactly what it was designed to do. The Fifth Amendment exists because the alternative is a government that takes your property for whatever it decides to pay you. The protection is real. The cost is real. They are the same thing. In China, the legal premise is structurally different. All land is state-owned. Individuals hold use rights, not title. When a highway corridor is designated, the state is not purchasing from private owners. It is reallocating rights it already controls. Average land cost for a Chinese highway mile, approximately $400,000, against $12 million in American suburban corridors, a gap of $11.5 million per mile before the first survey stake enters the ground. $11.5 million per mile, across 53,000 miles of network. The arithmetic produces a number larger than the annual GDP of many countries, extracted purely from the legal structure of land ownership. Most people who debate infrastructure costs never reach this number. They talk about labor, union contracts, material costs. None of those come close to the land acquisition gap in raw dollar terms. Now here's what makes this more significant than it first appears. Land cost is the single biggest line item, but it is not the only one. Because even after securing the land, an American highway project faces a regulatory process so fragmented and expensive that it adds nearly $9 million more per mile before the first concrete truck arrives. And understanding how that process works, and why China replaced it with a single document, is the next piece of the puzzle. The approval maze versus the corridor decree. Imagine you want to add a room to your house. You need a city permit, utility sign-off, a structural engineer's stamp, near a wetland, a federal environmental clearance, in a historic district, preservation board approval. Each has its own timeline, its own fee, its own appeal window. Miss one and the whole process pauses. Now scale that up to 100 miles of interstate crossing, 3 counties, 2 watersheds, a protected wildlife corridor, and a town with its own zoning board. A new American interstate passes through an average of 47 separate federal, state, and local approval processes, 47 agencies, 47 windows for a procedural challenge to halt the project. The environmental impact statement alone averages 4.5 years from initiation to approval, 4.5 years before a shovel touches soil. Combined regulatory compliance cost across a typical American highway mile $9 million. Not construction cost, process cost. Here's what makes this critically important to understand. That $9 million is not waste in any simple sense. Most of those approval processes exist because real damage was done when they did not. Highways carved through communities without environmental review, wetlands drained without consequence, neighborhoods demolished without recourse. The regulatory framework is scar tissue from decisions that went badly wrong. You may disagree with where the line is drawn now, but the line was drawn in response to something real. China's approach in 2004 was architecturally different. The National Expressway Network Plan issued corridor-level authorizations covering thousands of kilometers simultaneously. Provincial governments received alignment authority. Local design institutes received standardized specifications. The approval chain compressed from 47 processes to one coordinated framework. Regulatory cost per Chinese highway mile, approximately $180,000, against $9 million in America, a gap of $8 million parts $800,000 per mile. Now add the running total. Land acquisition gap, $11.5 million per mile. Regulatory compliance gap, $8,800,000 per mile. Combined, over $20 million of the $44 million total, without touching a single construction variable. But the construction variables are coming, and one of them adds another $8 million per mile through a mechanism so logical and so invisible that most Western analysts miss it entirely. It is not about what China builds with. It is about who owns it and how close they park it to the job. The vertical integration weapon. Picture a highway construction project in America. The State Transportation Department issues a contract. A prime contractor wins it and hires a geotechnical survey firm, a design engineering firm, an earthworks subcontractor, a drainage contractor, a concrete supplier, an asphalt company, a paving subcontractor, a signage firm, an electrical contractor, a landscaping subcontractor. Each carries its own overhead, profit margin, bonding requirement, and mobilization cost. Stack those layers and construction economists calculate a combined overhead load of approximately 22 cents on every dollar of direct construction cost. Before a yard of concrete is poured, 22% of the budget has been allocated to organizational structure. Now here is the detail most people never think about. China's major state-owned construction groups do not subcontract cement supply. They own the cement plant. They do not hire a separate rebar supplier. They own the steel mill. They do not contract out asphalt production. They own the batching equipment, and they move it. When a project activates in a new province, the construction group positions a temporary production facility within 3 to 5 miles of the active construction front. Raw materials travel miles, not hundreds of miles. One organization, one budget, one chain of decisions. Independent analysis of a mountain expressway project in Guizhou province quantified this vertical integration effect at $8,300,000 in reduced material and logistics cost per mile. Not from building differently, from owning the inputs and eliminating the distance between production and placement. Hold 3 numbers in your head. Land acquisition gap, $11.5 million per mile. Regulatory compliance gap, $8,800,000 per mile. Vertical integration advantage, $8,300,000 per mile. Total, $28,600,000. Out of a $44 million gap, 3 structural decisions about land law, governance architecture, and corporate ownership account for nearly 2/3 of the entire cost difference. Without touching a single labor rate, the remaining gap comes from 2 places. One is the assembly line manufacturing logic you already understand. The other is something buried so far into the Chinese highway engineering standard that most Western analysts never find it. It does not appear in the construction cost breakdown. It appears in the design document, in a single number. And once you understand what that number means, the entire story clicks into place, because it was not a cost-cutting decision. It was a strategic one, and it reveals what the highway network was actually built to do. The road built to expire. There is a number buried in the Chinese highway engineering standard that almost no Western infrastructure report ever mentions, not because it is classified, because it does not appear in the construction cost breakdown, and most analysts never look past the construction cost breakdown. It sits in the design specification in the section on structural service life, and the number is 20. Chinese expressways are engineered for a 20-year service life before major structural rehabilitation. American interstates are designed for 40 years. You heard that right, half as long. Now, before you reach the obvious conclusion that China is cutting corners, hold that thought. The reasoning is not negligence. It is not a budget shortcut. It is one of the most deliberately calibrated decisions in modern infrastructure history. And once you understand the logic, you realize it was never really about the road at all. Here's how it cascades in practice. A 40-year road requires thicker base courses, the compacted gravel and aggregate layers beneath the visible surface, denser subgrade treatment, heavier bridge deck reinforcement. Every difference cascades through the material volume calculations for the entire project, the engineering estimate for material savings from a 20-year versus 40-year specification, sahent, $6 to $9 million per mile. That closes the final layer of the cost gap. Design life, not labor. But here is what makes this the most important part of the entire story. China did not choose 20 years because it could not afford 40. China chose 20 years because 40 was the wrong answer to the question it was actually solving. Think about a temporary bridge. Engineers sometimes build one to move workers across a river while they construct the permanent structure. Nobody calls the temporary bridge inferior. It is exactly the right structure for its purpose, built for the duration it needs to serve, not a day over-engineered beyond that. China applied that same logic to an entire national highway network. Here's what the highway was actually built to do. In 1990, 73% of China's labor force was rural. Those 400 million people, more than the entire current population of the United States, were physically cut off from the coastal manufacturing clusters about to become the engine of the global economy. The highway network's primary job was not freight. It was restructuring the labor market. Make 600 million people commutable to factory corridors and port cities, fast enough to industrialize the most populous country in human history within a single generation. By 2015, the rural workforce share had fallen from 73% to 28%. That transition, the largest labor market shift in recorded history, happened in 25 years. The highway was the mechanism, not the destination, the mechanism. And the 20-year design life made perfect sense within that logic. By the time those expressways approached end-of-service life, heavy industrial truck traffic would already have peaked. High-speed rail was absorbing long-distance passenger travel. Container rail was absorbing bulk freight. Building a 40-year road for a 25-year traffic pattern is not engineering excellence. It is overbuilding. If the vertical integration numbers surprised you, what China did next with rail and semiconductors is even harder to believe. Hit subscribe so you don't miss it. Now here is what most people get wrong about the verdict. The conclusion is not that China builds better. It is not that America builds worse. It is that each system produces exactly the infrastructure its governing structure was designed to produce, at exactly the cost that structure generates. America's system was built to protect communities from infrastructure imposed without consent. The Fifth Amendment protects your land. The Environmental Review protects your watershed. The 47 approval processes protect your neighborhood's right to be heard. And the price of that protection shows up exactly where you would expect. $50 million per mile, every mile, as a direct function of what the system was built to value. China's system was built to execute outcomes already decided. Land reallocation without title transfer, corridor authorization at national scale, vertically integrated supply chains, a design life calibrated to a specific economic window, $6 million per mile, every mile, as a direct function of what that system was built to value. The $44 million gap is not an engineering gap. It is a governance gap, the mile-by-mile price of two completely different answers to the same question. Who does infrastructure serve, and who gets to decide? If this changed how you think about what it actually costs to protect the people a road runs through. Hit that like button and subscribe so you never miss what comes next. Now I want to hear from you in the comments. Do you think America's approval process protects communities the way it should, or has it become a system that makes building anything nearly impossible? Leave your answer below, because I have a feeling this one is going to split the room.